Welcome everyone to today's crucial lesson, where we'll dive deep into a powerful, yet often overlooked aspect of event-driven architectures: Kafka message headers. These seemingly small pieces of metadata are critical for building resilient, observable, and flexible distributed systems, especially as your microservices grow in complexity. By the end of this session, you'll be able to clearly define what Kafka message headers are and understand their fundamental role in modern software design. We'll explain precisely how these headers become the backbone for advanced capabilities like distributed tracing, allowing you to follow a single request across dozens of microservices, and how they enable dynamic A/B testing for real-time experimentation with new features. You'll also learn the architectural patterns for effectively injecting, propagating, and extracting these headers within your systems. Finally, we'll cover essential production considerations to ensure your header-based systems are robust, secure, and performant in a real-world environment. Let's get started on unlocking this powerful tool. So, what exactly are message headers in Kafka? Think of them like the headers in an HTTP request. They're essentially key value pairs attached to each message, but they are entirely separate from the main message payload. This separation is absolutely crucial. Headers allow us to carry important metadata alongside our core business data without polluting or altering the primary message content itself. Why does this separation matter so much? Because headers are the ideal mechanism for managing cross-cutting concerns. We're talking about vital operational tasks like distributed tracing, which helps you track a user's journey across many services, or implementing A/B testing to dynamically route users to different experiences, or even propagating security contexts and authentication tokens safely. By using headers, your core business logic remains clean, focused, and independent, while these operational and observability concerns flow seamlessly through your event-driven architecture. This makes them an essential component for building production-grade, complex microservice systems that need to scale. Now, let's zoom in and look at how these headers actually move through your system, from their origin to their consumption. Our header system typically consists of three distinct interconnective layers. First, we have the injection layer. This is often at your API gateway or the very first service receiving a user request. Here, critical headers like a unique trace ID or specific feature flags are programmatically added to the message. Next, the propagation layer takes over. This is where Kafka shines. Once headers are attached, Kafka automatically carries them along with the message as it flows through various topics, ensuring this vital metadata stays consistently with the data. Finally, the extraction layer is where your consumers come in. They read the headers from the incoming Kafka consumer record, extracting the metadata needed for their specific business logic or operational decisions, such as routing a user to an A/B test variant. This creates a clear, observable control flow. A user request hits your API gateway, headers are injected, the message reliably travels through Kafka, and then consumers extract those headers to inform their actions. Let's get practical and explore some key applications. Headers are incredibly versatile. For distributed tracing, we use headers like trace ID to uniquely identify an entire request journey across multiple microservices, and span ID to mark individual operations within that journey. This provides an invaluable map for pinpointing performance bottlenecks. For feature flags, a header might contain a JSON object like feature flags, letting you dynamically enable or disable features for specific users or segments without any code redeployment. Imagine routing just 10% of your users to an experimental new feed algorithm. The implementation strategy is straightforward. During message creation, services use Kafka's header serializer to inject these headers. Kafka handles their propagation automatically. On the consumer side, you extract headers early in the processing pipeline using consumer record.headers, typically storing them in a thread local context and then using them throughout your business logic execution. This approach ensures consistency and flexibility. As you implement headers in production, keep a few critical points in mind to ensure robustness and performance. First, header size limits. It's crucial to keep your headers small, ideally under 1 kilobyte total. Large headers can impact broker performance, so use efficient serialization. Second, consider schema evolution. Your header schemas should always be designed for backward compatibility. New fields should be optional with sensible defaults to prevent breaking changes. Third, security is paramount. Never put sensitive data directly into headers. Instead, use opaque tokens that reference secure storage systems, protecting user information. Headers add minimal overhead, but unlock powerful capabilities like debugging complex distributed issues or running millions of A/B tests daily, similar to how Netflix and Uber leverage them. So, to wrap up, we've defined headers, explored their architectural flow, and seen their practical applications. Now for your self-assessment. How would you design a new feature, perhaps a user personalization engine, leveraging Kafka headers in a distributed system? Consider the injection, propagation, and extraction process and the production considerations we just discussed.